Hi everyone, it's Coach Fred here, and today we're going to be talking about solving a system of equations in 3 variables. But we can't really do that without going back to a review of what you did when you were solving a system of linear equations or a quadratic linear system. So I want to remind you that when you solved a system of linear equations, you had 3 possible solutions that could happen, and this was because you were dealing with 2-dimensional figures, 2 lines. They're in the 2-dimension. So they could either give you exactly one solution, because the solution is actually the point of intersection. It could be infinitely many solutions when the lines were exactly the same. And then there could be no solution when the lines were actually parallel. It meant they had the same slope. So those were the possible solutions you could get if you tried to solve a system of 2 lines. You then extended this when you looked at quadratic linear systems, a quadratic equation and a linear equation. And so you can see that we also have some situations that can happen where we could have 2 solutions, right? Because we'd be looking for 2 points of intersection. You could have one solution where that line just hits the parabola in one place, but you could also have no solutions where the parabola and the line never intersect. But again, these are 2-dimensional equations or functions. So when we look at a system of 3 variables, it's interesting because now we have to think about the 3rd dimension, a 3rd variable, an x, y, and z plane. So I like to think of an x, y, and z plane like a cube. If I was thinking about a cube, putting it in the plane, x and y wouldn't be enough. I'd have to extend outwards. All right, when that happens, when we're working in a system of equations with 3 variables, you're looking again for a point of intersection, but of 3 distinct planes. And so you could have a unique solution where they all intersect and you have this common point of intersection. But then you can have this situation where like 2 of the planes intersect, but not all 3. And that would be no solution. And then you could have infinite solutions where they all intersect and they intersect actually in a line instead of in a point. All right, but we've got to get to the nitty-gritty. How do we actually solve these? Well, basically what you're doing is substitution, and elimination. So you're kind of using all these things together. So let's look at a basic example. I can tell I have a linear system because I have an equation that has 3 variables and then 2 other equations. They could all have 3 variables, they could have 2 variables, but when it's basic, I can see quickly that they're telling me that z is 3. So I know one of my coordinate points, and when I write the answer, I'm going to be writing it in the form x, y, and z. All right, so what I can do is I can substitute 3 into the 2nd equation. So 2y plus 3 equals 1, and then solve for y. That would give me 2y equals, I'm going to subtract 3 to both sides, so -2, and then divide by both sides by 2, so y equals -1. All right, so now I've got my -1, I've got my z of 3, I've got to find my x. Okay, so that's still my unknown. But now I have a z and I have a y, so I can go to the original equation and plug them all in. So 2x minus 3y minus 3 plus 6 equals 13. All right, so then 2x plus 3 equals 13. 2x equals 10, and so x equals 5. And so that's the solution. So it means that this line, this plane, this line, and this line actually intersect at the point 5, -1, 3, which is in the x, y, z coordinate plane, so the 3-dimensional plane. That was a very basic example because I gave you the z that I could plug right in. A little bit harder when you have equations with 3 variables. So the goal when this happens is for you to pair up equations to actually create a 2-variable system. Now, once you decide what variable you're going to get rid of, then you have to stay consistent with that. So let's try this out. If I pair up equations 1 and 2, these 2 right here, x plus y minus 2z equals 7, and -x plus 4y plus 3z equals 2. Well, I can see that if I use elimination and I add the equations together, I'm eliminating x because they're opposites. So I'm going to go ahead and do that. That's going to give me 5y plus z equals 9. All right, but you can see now I have an equation of two variables. So now I have to pair up two different equations and get rid of the same variable. All right, so I'm going to do that. I'm actually going to pair up these guys. The reason I liked them is because I know I have to eliminate x, and this one's already negative. All right, so that gives me negative x plus 4y plus 3z equals 2, and 2x minus 3y plus 2z equals negative 2. All right, now I have to make the x's the same, so I'm going to multiply the top equation by 2, and that's going to give me negative 2x plus 8y plus 6z equals 4. Okay, I'll cross that out so it's not my way anymore. Always want to make sure I forget to multiply something there. Be really careful. Okay, now I'm going to add the equations together, and these get eliminated, and I get 5y plus 8z equals 2. All right, so now if I think about that, these guys are now an equation in two variables, which I know how to solve from my Algebra 1 class. So I'm going to pair them up. And I'm going to eliminate y, so I'm going to multiply the top equation by a negative 1, giving me negative 5y minus z equals negative 9. All right, so we're going to add these equations together, and we're going to get 7z equals negative 7, so z equals negative 1. All right, so we've got our z of negative 1. I now have to get my y. Probably going to plug back into this equation. So 5y minus 1 equals 9. So 5y equals 10, and y equals 2. All right, now I got to go back to one of the original equations, and I'm probably going to go to that first one. So I have my z of negative 1 and my y of 2. So I have x plus 2, and z was negative 1. Z was negative 1, so that's going to be plus 2 equals 7. So x plus 4 equals 7, and so then x equals 3. So the solution I get for this system would be 3, 2, and negative 1. All right, so we're going to do one more example. I recognize this video has been a little bit long, but I think it's well worth us doing a harder example together. Okay, so let's look at this harder example. And you may choose to try this on your own first and press pause. I might do that now that you've seen an example or two and see what you can come up with. All right, but I'm going to do it. So I'm looking here quickly, and I see that I want to decide what variable I'm going to eliminate. And I actually decided to pair up these two equations and eliminate x because I had a 2x and an x. And a negative 2x. So I'm going to pair those up. So I'm going to neatly put them over here. So 2x minus y minus z equals 2, and negative 2x minus 2y plus z equals negative 2. Now you're going to see what happens here. I notice the z's are also going to actually get eliminated when I add these equations. So let's see what happens. I get negative 3y equals 0. Divide by negative 3. And so y equals 0. That actually helps us, doesn't it? Okay, so now we're going to pair up another set of equations, and I'm going to plug in the 0. So I'm going to actually pair up these guys, and that's going to give me, when I plug in 0, x plus 3z equals negative 13, and negative 2x plus z equals negative 2. Because that y got rid of. So now I have a system of two variables. I'm going to multiply the top by 2 and rewrite it below it neatly. 2x plus 6z equals negative 26. Cross it out so it doesn't get in my way. And that's going to give me then 7z equals negative 28. So z equals negative 4. Okay, so if z equals -4 and we know y equals 0, we can go back to any one of the equations. I'm actually going to pick that one. So 2x minus 0, that goes away, plus 4 equals 2. So 2x equals -2 and x equals -1. And so that gives me an answer of -1, 0, -4. All right. And that's how you solve a system in 3 variables. They do get harder. You do have to be incredibly neat when you're doing them. But again, remember, pair up 2 equations, eliminate the easiest variable to eliminate. Once you've done that, though, that's your variable to eliminate when you pair up the other 2 equations. You're creating a system of 2 variables and solving it however which way you want, but I tend to use elimination a lot. Okay, guys, hopefully that was helpful. Have a great day. So I just realized that you might want to try one on your own. So I'm going to give you an equation to try on your own, and let's see if you can get the answer. So I'm going to give you x plus 3y plus 2z equals -1, and -3x minus 2y plus c equals 3, and 2x minus y plus 3z equals -8. So write that down carefully. I'm checking it to make sure I gave it to you properly, and I did. And the answer to this one would be -2, 1, -1. -2, 1, positive 1, -1. All right, so what I suggest you do is try it. See if you get the answer. If you make a mistake, if you don't get that, try it again. And then if not, bring it to class and we can go over in class. Have a great day.